Is good, and you have to verify the ground. In that case, you just reverse the leads. We're going to go to a known good power source and hook our red lead to battery power, and then we're going to take our black lead and put it on the ground and see. So if the battery, for example, has 12.6 volts, we hook the battery here and go to the ground over here, and we only got 11. That means we're losing 1.6 volts on the ground side between there and back to the battery, right? Okay, so you have to verify both sides of the circuit, and to do that, one of them has to be a known good source. Okay, and this is a problem that sometimes people don't look at. You go back there to check trailer lights or something and hook one onto the frame, but it's rusty and got dirt and stuff on it, you don't have a good ground, you go to check voltage, man, you only have 4 volts, you don't have any volts, you got a voltage problem. No, you got a bad ground, okay, from your test meter. And that's the reason when we first started this, everybody made a set of test leads, so you could make yourself a known good ground. There's times working on a seat or under a dash, back at the back, where everything's plastic. It's hard to get onto a known good ground. You're trying to check something, you can't find a place to put your lead. That's why you have the jumper leads. Always verify that one of your test points is known to be good. So if you're checking available voltage, you have a known good ground. If you're checking the ground, you need to make sure you have a known good power source. Okay? I'm going to cover just a little bit more of this later on, a couple of things to do. All right, we're down to this one. Voltage drop. Voltage is pressure. Anytime we have a loss in pressure or voltage in a circuit, it can make it not work correctly. Electricity doesn't know if you have 2 lights in a circuit, in a series circuit, or a light and a bad connection in a series circuit. The only thing it recognizes is I have resistance I have to overcome. It takes pressure to overcome that resistance. So if I have a wire, I brought some examples here. If I have a wire or a cable like this one, you can see this one is swollen up. These, can you see them? They're swollen up, they're corroded. The electricity runs on the outside of the circuit, not the inside of the circuit. So if I check from here out to the end of this one, and I have a lot of corrosion in here, I can lose voltage or pressure to get from here to here because it has a hard time pushing through all this resistance right here. It's on the same piece of wire. So a voltage drop is from this end of the wire to this end of the wire, but the only time you will find a difference in pressure is when you're pushing current. So remember, a voltage drop has to be done with electrical flow going through it. Okay, you can't just check from here to here because right now the difference is 0. If it's hooked up, the difference is 0. Okay. When I turn on the headlights and I'm trying to run 9 amps through this circuit, through the headlights and back through here, that's when I'll find a loss in voltage. So remember, a voltage drop will only be accurate when there's current flow. And so if this is hooked up to the car, and I go to the engine block, and the negative post on the battery, and say, do I have voltage drop? Well, do I have voltage drop now? No. If it's hooked to the battery and there's no current flow, no voltage drop, what am I going to find it? I'm trying to start the car and running current through this wire. And when I run current through it, if there's resistance, it uses part of the pressure to overcome that resistance, and I have voltage drop. Okay? And people get confused. A voltage drop is between this end of the wire and this end of the wire. Same wire. And it's how much pressure it takes to get from here to here, or vice versa. Okay, so we spent some time on voltage drop. All right. You guys all right with this? You know you have to have current through it? So if we're checking a redundant ground, for example, that goes from the battery over by the radiator support bracket, and it grounds the headlights. Remember, we're using the body of the car as a piece of wire. And so we're going to have the fan motor go over to the fender well, and we're going to have the lights come up to the radiator, ground to the radiator support, and you know, your stereo and all this stuff grounded through there. Well, the only time you're going to find out if you have a problem between the battery and the body of the car is when you have current flowing through it. You can't just take your meter and touch it and see if it's good. You got to turn on the lights and turn on the wipers. Remember us doing that?
Yep.
Okay. I'm done with this one.